some ISI. This is ISI entrance only, but apparently this is some other entrance like I think MS Economics. But the questions are, yeah, these are like little advanced in knowledge, but much easier in hardness, right? In that sense, but may require a little bit more, yeah, terminology. Let's see. The first question is pretty standard, but we'll do it. Okay. So we are looking at a continuous function. Okay. We are looking at so this is 3. Somehow this is 3 part A. Okay. We are looking at a continuous function. So one second, it gets misplaced and it's not good. So we're looking at a continuous function from 0 to 1 to 0 to 1 itself. This is important. Okay. Now we want to show that there exists. Oh, okay, no problem. We will discuss that also. Maybe the order has got, I'm not, my order thing is very bad. Yeah. So can we just quickly do this? Because this all of us know, I think. Okay. So I think Chandan, you, same thing? Right. Yeah, G of 0 and yeah. So you just compute G of 0 and G1 0 and then you can finish. So I'm not doing this because since both of you know, so I'm not doing it. But let's see. I mean, so this is a situation in which you have a fixed point, right? X0 is a fixed point of the function. Okay, so this x0 is a fixed point. Okay, fixed points are very desirable. They're very good. So let me let's see. So see, why is there a fixed point in this case? You see, there is a fixed point in this case because the range is sort of, contained in this case, it's equal to the domain, right? The range is equal to the domain. You can also show that if it's contained in the domain, then also the same thing will happen. Do you guys agree? Right? If I replace it by a comma b, where a is more than 0 and b is less than 1, then also this you can prove this thing. Okay, so whenever there is a contraction, so there is a domain and then the range is a contraction of it, then there is a fixed point. Okay, fine. So let's not say more words. Yeah, let me just give a problem. Okay, I think this maybe you guys have not done. So I'll remove this condition. This is very easy because since only you have 2 of you here, so let's do some interesting stuff maybe as much as I can. Show this if f is a contraction. And what do I mean by contraction? I mean fy minus f of x, okay, is less than, so let's just make a simple case, less than half of this or mod of this. So this is not a generalization, but it has a similar idea, and obviously the problem is also similar. So let's try to do this one. Yes, obviously, yeah. So I should write that. It's not obvious. F is continuous. Whatever, continuous. So if there are 2 points A and B, then wherever they go, the image, the image will be like half of this distance. This is. think. Sorry. So maybe this will take some time for you guys to think, right? So why don't you try this for homework? Or think, let's take a minute and see if you get any ideas. So this may be difficult to get started with. Okay, so the idea is, see, such a fixed point. I mean, how are fixed points obtained? Fixed points are obtained at the end of a limiting process, right? You continue something on and on and on and on and on. And when you take the limit of that process, the limit is usually a fixed point. Okay, so what you have to do is you have to start with an arbitrary point t, and you have to go on and on, meaning that you have to compose the function on and on. If you draw a picture also, you'll kind of get an idea that this is going to converge to the fixed point. I mean, the y equal to x line. It will lie somewhere there. You have to go on and on this thing. And using this, you have to try to show that there's an exponent. See, if you can show that this sequence has a limit, right? If you can show that this has a limit, you know, if this limit is whatever L, then L is a fixed point, right? If you can show that it has a limit, just giving a rough sketch, right? Then you can take f of it, one second, right? Then you can take f of it, and you will get that that is also a fixed point, right? Because I mean, the limit of f to the power, I mean, f composed n plus 1 times, that's also going to be L. So FL equal to L. So that's how you will get, but you have to show that this has a limit, and that's the task. Okay, so Purvi, just 1 minute here. I just did an extension of the question because since you were not there, so do it. Yes. Okay, let's see. Let's see. Okay. So, okay, let's since Purvi has just joined, so let us just review this question once again. So there is this question, Purvi, I think you know the question. So that there is, I'm just writing it on the right first. Okay, that f is from 0, 1 to r, and no, not 0, 1 to r, 0, 1 to 0, 1, right? In this case, right? And f is continuous, and obviously we want to show that it has a fixed point. You obviously know this question. So are you able to do this question? That's the first thing, because then we were trying to do a little more advanced version of it, you could say. Yeah, okay. Right, yeah. So because this has a slightly new idea, which I think, I mean, others are aware, but if you're not aware, then it can be a little strange, okay? So let me try to do this question in a slightly different way than I did right now. We just did it 5 minutes back, but let's do it in a slightly different way. You see, it's always we should draw the picture. See, you want to show that this is a fixed point, right? Now, what does it mean? What does it mean geometrically for this x naught to get mapped to x naught, right? What does it mean? Let's try to understand that. So we have this thing from 0, 1, right? And the good thing is the image is also in 0, 1, right? So you can just look. This thing is like this. And this picture will be important for all of you, because the more advanced question that I gave, which other two and others will try, this you will need this, and even other versions of it, you will need this picture. It's very simple, but Now, let's just draw an arbitrary function, right? Because nothing is given about f. If you just draw an arbitrary graph, it can be anything, okay? Anything you want to draw, like this, right? Now, what does it mean that f of x naught is equal to x naught geometrically? What does this mean? How would anyone if you can say, how do you see this in the picture? No, not necessarily. No, not necessarily. It's not increasing. As I've said, like as I've drawn, like this is just any function, right? So can anyone, so what the question is that this f of x naught equal to x naught, what does this mean pictorially? It means that, see, it means that there is a point x naught and the image is always f of x naught, right? So if we take, so there is a point P, and P is f of x naught. Sorry, P is x naught comma f of x naught. All right. Now, if x naught is equal to f of x naught, if x naught is equal to f of x naught, what does that mean? Anyone? Pictorially, what does that mean? Well, it just means that this point P is on the line y equal to x. Because that's what the point y equal to x means, y equals x. Both the coordinates are equal. Is that right? Okay. If you look at the point y equal to x, then every point on this line has both the coordinates same, and any point which has both the coordinates same is on this line, right? And so this condition that there should be a point where input and output is same is basically saying that there should be a point where this graph intersects the y equal to x line. But it surely does, right? I mean, you cannot draw a graph which does not intersect the y equal to x line in this circumstance, right? Where you have this y equal to x line, you cannot draw me a graph which doesn't intersect the y equal to x line, right? I mean, you can do anything, but you have to eventually intersect, or you have to intersect. There is no way to not intersect, right? Because you want to go to this line. The last output will be on this line and the first one. Basically, that is in some sense the proof. Okay, that this function will intersect the y equal to x line. Okay, so I'm yes, so this is certainly not the solution. I'm going to say the formal solution, but this will at least tell you that this fact is true. Okay, and even writing this is not completely wrong. I mean, you may not get all the marks, but you understand. Yeah, this is a good explanation. But yeah, you have to write a proof. So we'll do a proof. The proof is very standard. It's very standard. So we'll just see that technique. It's standard. See, so I mean, let's see. So yeah, you want to show that f of x naught is equal to x naught. Well, and how would you translate this? So usually we translate this into a condition where something is zero. One should always try to do this. I mean, in the easy question, this is like an easy question in that sense. This is what we want to show, right? We want to show that this thing is zero. So what do? We make a function out of this, right? We make a function out of this. What function can you make out of this? But there's only one function you can make, which is fx minus x. Right? So we make this function. Okay. Now what do we want to show? We want to show that there is a point where the function is zero, right? We want to show that there is a point x naught where g of x naught is zero, right? This is basically the question, but I'm translating it like this because it's easier to show that something is zero. Okay, I mean, even if you don't do it, it can still be done, but it will become a little more messy, but either way, it's not hard anyways. But I'm translating. This translation technique, whenever there's an IBT question, more often than not, this translation technique is enough in the easy questions, okay? But obviously in harder questions, it may not be enough. There you have to split the function in an interesting way, okay? Right, all right. So that's the thing. And so now how do we show that this function is zero? Well, if you want, now this is a different function, right? Now, if you want to show that something is zero, you show that it is positive at some point and negative at some point, right? That is the way to show that it is zero at some point, right? A G, if you want to show G is zero at some point, you have to show it's positive at some point, negative at some point. Well, what are our candidate points? There is really no candidates, right? There is only 0 and 1 which we can work with. Those are the only kind of, things. Well, this range is, remember, 0, 1. It does not work if the range is R, if it's given to be R, or if, this will work only when it's kind of this interval is kind of getting contracted to this interval. And in that contraction process, something gets fixed. Okay, it's a very fundamental thing. It's not just about these things. It holds in general, but yeah. Just do it at 0. You see, if you evaluate at 0, it becomes f of 0. And if you evaluate it at 1, it becomes f of 1 minus 1. So now can anybody complete it, please? Chandan, maybe you can say. That's right, because the range is not more than 1, right? And so you see, if at some point it is more than equal to 0, if it's equal to 0, there's nothing to do. But it's more than equal to 0, and some other point it is less than equal to 0. Well, this means that it has to be 0 at some point, and that is the IVT. In fact, it is already given in the question that you have to use IVT. So basically, there is some point, I don't know, some x naught where it is 0. Okay, that's simple. Okay. Oh, because G0 is F0. So what is f of 0? F of 0, well, you don't need to know the value of f of 0, but you know that it cannot be less than 0. Because the range, okay, maybe I confused you in the beginning, right? I wrote R here. So just you have changed here in the top of the screen. I've changed this, right? Okay, yeah. Because initially I had written R for a different question. Okay, so you see, it's a simple application of this thing. Okay. Yeah. All right. So then we'll move forward. Yeah. So Chandan and Prasad, you guys should definitely try the harder version. Okay. We will do it in the analysis class. Try the harder version also, which I gave. But yeah, for now, let's move on, because before we go into the harder ones, we have to complete this everything first, and then we should go. So the latter questions are not so trivial. This one is a easy one to start with, but let us see what is the next question. One second, I had closed my WhatsApp in between, so I missed it. Yeah, right. Okay, so these are some small things. So, if so f is continuous is always the case. Everybody knows the question, so I don't need to repeat it. If this is the case, then does this imply, this is a question mark. We don't really know if this is true. Does this imply that f has a fixed point? Or, yeah, you understand. Does this imply that there is a x naught? So all that is being changed in the question is it becomes an open interval now. Again, yes. Okay, you're saying it is true. Okay, draw a picture and see. Draw a picture. So I've shown all of you a pictorial model. Try to draw and see. I'll soon say, Raghav, you can also tell me what you think. Okay. Okay, so you see, he's trying to do the same thing, similar thing. Okay. Which is greater than, no, it's not equal, right? It's only greater than 0. Oh, oops. What was I thinking? Sorry, I was thinking something wrong then. Okay. Yes. Right. Yes, yes. Uh-huh, uh-huh, uh-huh. Okay, no, no, okay, okay, fine. So you are saying by okay. So far, let me just Chandan before you say. So far, Purbi, have you do you follow his argument so far? What he's trying to say? Mm-hmm. Mm-hmm. Yes, right. It can be anything, but it is certainly f of zero, right? Because the very definition of G tells us that, right? And that tells you that it is f of zero because f of zero minus zero that is greater than zero. So that is fine, right? Okay. Less than one also. Yeah, but that is there. Okay, but what he has said, there is something wrong in that. I am feeling I may be wrong. Chandan, what do you think? What do you wanted to say something? Mm. So now you guys are kind of seeing something, right? Some mistake. So basically, I said, see, this is a question about you have to just kind of answer in yes or no at least, or then give a counter. But how do you feel that this correct or not correct? Go to the picture. Go to the picture. These are very simple looking questions, okay, but they can fool you, okay. So yeah, so it's fine. Let's see. So as Chandan has kind of pointed out, see, you can take a function like this. You can take this kind of function. Now you see. So this kind of function, I'm not defining the function right now. You guys can define it. But can anybody quickly give me just y equal to x square, right? Sorry, yeah. Parabola, y equal to x square. Yeah. Y equal to x square le lo. But my point is that this is not going to intersect the line y equal to x. So in the beginning, I had said that, and you guys know this, but that fixed point means intersecting the point y equal to x, intersecting the line y equal to x, right? Because that's where f of x naught becomes equal to x naught. Now you can see this situation in this graph. First of all, see, I'm going to remove something, okay? This end point I have to remove, top end point of the rectangle, okay? And this bottom thing that is at the origin, that also I need to remove because these are not in my domain. The domain is open interval. Okay, now does it intersect the y equal to x9? Hmm. Yes. Yes, and in between also it doesn't intersect. Right? Because the between, and obviously we all of us know the square of a number is less than the number. So the answer is no. And that can be said in so many ways. I mean, someone can just say square of a number. If someone just knows, I mean, everybody knows square of a number is less than the number when it's less than one, when greater than zero. Then they can just say the answer is quickly no. So it really depends on how quick you're thinking and how openly you're seeing. Okay. So then, okay, ठीक है यहाँ से तो we are getting that the answer is no, and we also got a counter example. Very nice. So that's why this picture model was good. Okay. But then where is, but then this seems to suggest that the answer should be yes. So then where is the mistake? This we need to understand clearly, right? You shouldn't be confused in the exam. अच्छा क्या हो गया? This is looking correct, but then it's also looking wrong. I, so where is the mistake in this? Why? Oh yeah, it is f of, okay, okay, right. Okay, I think that's what Purbi, that's what you asked, right? How is g of 0 or something like that? Maybe. Oh yeah, yeah, yeah. Yeah, yeah. So that is my bad. Yeah, that is absent-mindedness. Sorry. Yeah. So that's what you wanted to ask that time. I didn't understand. Sorry. Yes, it doesn't even make sense, right? Doesn't even make sense, right? Sorry. Okay. So yeah, see, this is wrong, and so fine. So all of us learned something that's very good. Yeah, I also. And so this is the thing. It's very simple, but okay. Let's quickly move to the next question. Um, So this time, let's see, we have to do as many as we can. So because these are not difficult questions, these are not deep questions, these are but we have to do it quickly because that is also very important time in the exam. So the next thing, the next part is, I'll just write it in full kind of. So this time the domain is broken up. Domain is broken up, but it's same as the range. So the domain and range is the same, but it's broken up. It's not one interval. So yeah, will there, so I'll just write, will there be a fixed point? Okay. Just a different language. If we get used to these things, will there be a fixed point? No, it's continuous. No, a function is continuous. Interval is not continuous. So you think the answer is yeah. So you can tell me. It's just safe to give a function, right? Yeah. So you see, again, we're just going to use the picture. Okay, that we had said intersecting the y equal to x line. So you have to just avoid the, if you just make this function avoid the y equal to x line and see if you can avoid it. That's all. Y equal to 3 minus x. Okay, let me see. Let's see. So this is 2 and 3. So you're saying y equal to 3 minus x. Okay. Yeah. So it's a very smart example. So he's basically exchanging the intervals, right? So the range is, yeah. Some example we can easily make, but it's, yeah, like this. Yeah. So basically just do that. Just take this 0, 1, 0 to 1, and that you can map here, right? And this 2, 3 interval you can map in the 0, 1 interval. And there is no problem in continuity. It is continuous. Okay. I see at 1, it's not your responsibility, right? Because this is 1 to 2 is not in the domain. So it's not your problem that it is broken line. At 1, it is left continuous and that's all. So it is continuous. Okay. Because more than 1 plus h is not even there. So it's not your problem. So it is fine. It is continuous. And it clearly doesn't intersect the y equal to x line. Okay. And obviously this doesn't have a fixed point also. It's clear anyways. And you can just solve it and see. The fixed point will come between 1 and 2 or something like that. Okay, which is not in the domain. So yes. Mm-hmm. Mm-hmm. Yeah, f is continuous is written. Yeah, and that's why. So you have to take this domain. Yes, no. So initially they have said X is the domain, which means that they're just giving a name, like we are going to call the domain X. Okay. And later on, they're saying later on we'll use this X to refer to the exact things which they want to refer to. Okay, and that's what they're later on doing. They're putting different, because every time they can't say X is the domain, X is the domain. It's like a pronoun thing, right? So they're basically using it. That's, yeah. But the domain is changing every time. Okay, X is just a placeholder. Okay. So this is a counter example. So yeah. So the picture, knowing it pictorially is helping us all the time. There is no doubt. Yeah. So now quickly, let's quickly move to the, okay, the third part, I'm, third part, I'm leaving. You guys can try it, because if I do everything, then it's not good. Third part, I'm just leaving. Okay, moving to the next one. Just try third part on your own. And yeah, let's move to the, sorry, I'm saying I will do part C. I'm saying B part 3, I'm not doing it. It's easy. You can do it. If you can't do it, then you ask me. If anyone can't do it, ask me later. But yeah, let me move to the part C. Okay. This time it is, okay. So now we don't have one function. We have a lot of functions, okay? But let me just write it like this. Open. Yes, yes, yeah, it is. Yeah, I know it is. Yeah, it's easy. Let's see, but let's do it. Okay, let's do it. It is easy, yeah. And also this is about proving. So it's even in some sense more easy because you don't have to think. But still, let's just do this. Yeah, it's easy, easy. Today we're doing easy stuff. The next day we'll do it. Good. But yeah, but we did get something wrong earlier. So it's a collection of functions, okay? It's a collection of m functions, and each of them will have a fixed point. Yes, because that's what we have to say. So we have to show, and if it's continuous, all the FIs are continuous. But we need to show that there is an x naught. Let me just write it once. When you show that there is I'm just writing x naught. I don't like to write x star. So there is f1 of x naught plus f2 of x naught and so on till fm of x naught. And we want to show that this is m times x naught. Okay. Okay. So maybe Chandan, maybe you can tell me first a little bit of steps. Just don't tell the whole thing. You can tell the idea clean first. Right. So it is just the same thing. Okay. So Purvi, you see, it's the same idea. Okay. There's no difference. We have to just prove something is 0 at some point. So we just make a function out of it first. So that we have to prove something is equal to something at some point, but we convert it. Yeah, but it's fine. I'm just writing this. I mean, it's okay. Yeah. We make this just like earlier. We make this function. We want to show it is 0 at some point. You just put the value. So just put g of 0 and check. Yeah. So check that g of 0 is more than 0. Check this. This is not difficult. Just right in front. And then we have to put g of 1. So less than equal to 0. This could be also equal to 0. Just by the same reason. Yeah, something. And so we have this. Yeah. Non-zero, right? So when this is less than equal to 0, because each of them is less than 1, right? Because that's what the range is. And then it's just the same solution, right? So it will be 0 at some point. Simple. It's just the same thing. Okay. Fine. Any questions? Any questions? Then you should tell me. Then okay. So then let's do one more question. Okay. I will not be able to complete all of it today. Okay. There were more questions which I think I didn't send to everyone. I forgot. Oh no, yeah, I did send. So which one should we do? Let's do the optimization question first, okay? And then we can see. Because we have to end on 9:30 next. We can do. But let's continue. So I'm doing this question marked 1. Yeah, so I'm not going to write. Yes, I'm just going to tell. So, but let me just write it actually. Okay. No, this is about a street. Did I share this with you guys? Let's see. Let me just write it. Okay. So there is a street. Okay. And this is represented. Yes. Even I've not read it very carefully. So, okay. And then there are 3 agents that live on the street. Okay. Okay. Well, let me not just, I'm not just leave the language of streets and all. Okay. I don't like it. So let's just see. So they have 3 points, x1, x2, x3, I think. Okay. Okay. I'm just making the question, just writing it, not making anything, just writing it mathematically. Sorry, there are 3 points in 0, 1, this interval. Okay. And they're in this increasing order. Simple. Sorry, 1 minute. Okay. And we basically want to find P such that x1, I think it's gone minus, yeah, x1 minus p square plus x2 minus p square plus x3 minus p square, okay, is minimized, okay, is minimized. So if anyone wants to say, they can say first. No, don't tell the whole thing, okay, just tell us in a way that we can, it will help us. We want to figure out a p somehow which will minimize this. These are the first steps towards more interesting questions, like there are methods, there are algorithms, sum of least squares, least distance, or what is it called? Anyways, I forgot the name. Okay. Anyways, it doesn't matter. Sum of least squares. Yeah, sum of least squares, I think it is called. Yeah. Anyways, so you see we have this thing. So yeah, have any one of you done this? Or any ideas? I mean, I'm not saying to complete this and such. Okay, so that's a good observation, right? Because this part is really not important. I mean, in the sense, not important in the sense that we cannot do anything with it. Yeah. Okay, that's there. Yeah, so then basically we are left with this 3p square and we are left with this minus. So remember x1 and x2, x1, x2 and x3 are fixed. Okay, we don't know anything about them. So let us think. So we want to minimize this, but this is just a quadratic minimization problem, right? Because x1, x2, x3 is again some fixed thing. You don't know what it is numerically, but you don't need to know it. You can give your answer in terms of x, y, and z, right? So I will just call this t. Now it is just a very simple question, which is just a quadratic expression you want to minimize. So can anybody say how to do this? This is very simple, right? Just minimize it. You can use a formula, you can take derivatives and use a formula, but I can, yeah, yeah, minus or you can just complete squares. So it's very simple, just t square by 9 minus t square by 9, right? And then that's simple. So we get what? So you see this thing is p minus t by 3 square is completing squares. This is 3t square by 9. Okay, so this is it, right? This is just minus 3t square by 9. So this is basically minus t square by 3. So the minimum will be x1 square, that because that part was always there, right? This part always here minus, and you can calculate and see, you can calculate it. But there's no controversy that this is the minimum. Is it right? Because this is at least 0. Okay, and so the minima is this. And you can make it 0 also, so no problem. Because you can choose any p, or am I wrong? If I'm wrong, you correct me. Okay, anyone has any doubts? Because there are some subtle things in this maybe which we are missing. So if you ask, then come out. So there is really no problem, right? Or can there be a problem? So what you have to be really sure about is, can you really find a P such that this is 0? See, if you want to minimize this expression, you need to make this thing 0. Is it right? Anyone doubts? So can you make it 0? And the answer is yes, because there's a t by 3. Because it's a t by 3, so this quantity t by 3 is between 0 and 1. That is important. Otherwise, it's not clear that you can make it. Okay. T by 3 is between 0 and 1 is important. Remember. That's why you can find a p. Otherwise, you cannot find a p, right? Because a p you need to be between 0 and 1. Okay. So you can make it 0 because you can put p equal to t by 3. It is legal because it is between 0 and 1. And so you can make this 0 and this will minimize the expression. And so this is a minimum. It could be positive, negative, I don't know. You guys can check it. Yeah, it is positive. You can check it if you expand, but this is the answer. And it's also positive, right? That's some inequality, but we don't need to use that here. Minimum. Any doubts? So let's move to the next question then. If there are doubts, you should interrupt me. So Chandan, did you do this in the same way or did you not do it, or how did you do it? It was not in the email? Oh, but you didn't check it. No problem. Okay. Yeah, so that was my mistake. Actually, I forgot. Okay, sorry. Yeah, but this was easy. Yeah, pretty easy. Okay, let's do the next one. The next one is maybe not so trivial. Yeah, I think the next one is more interesting. That is fine. Let me write the question. And next first part is always easy. Part B, part 1. Yeah, but let me write the question. So basically, I'll just say, given find P to minimize. This time we want to minimize some modulus. This is also called the taxi cab distance. Okay? And there is a reason, but let's not go into that. But here they're calling it absolute optimal. Yeah, because absolute values you're optimizing on. Yeah. So this is the thing, but here there is a kind of a hint, okay, in the form of a problem. Argue that P is if P is absolute minimal, then P has to be between x1 and s3. Okay. So P has to be in so you guys can tell me how to do this first part. And then you can think now. It's very good maybe to think on the spot. Like okay, you can give some simple reason. Someone, okay, that's I agree with you, Raghav. Others can give a simple reason as well, or some reason why. So this is the first thing, right? If I want to find a P such that the sum of the differences is minimized, right? Where should the P be? And the claim is that the P cannot be like here. P cannot be outside the boundary points of the question, in the sense that x1 and x3 are the boundary, right? P cannot be there. Okay. So well, that is very obvious, right? Because if P is here, then and if you take a Q which is somewhere anywhere inside, then you can check, right? That the distance is certainly. Yeah. Anyone wants to give a reason? No, not for minimizing, but just to answer this part. Okay, yeah, so that's a good thing, right? So if the point Oh, okay, that's also, yeah. But the point P is outside, okay? Then the distance that you're considering, first of all, you have to take this x1 minus x3, right? Or x3 minus x1, right? This one, yes, no, right, that's right. But for the point P, I'm saying, for the point P, you have to consider x3 minus x1 and more than that, right? You will use more than that, right? Already. I mean, P from P to x3 will be more than x1 minus x3, right? So I'm not writing that, but that is the thing. Yes, yes, yeah. No, that's right. But you see, but this is there. And but let me just write it clearly. So we have this P minus x3. If the P is outside there, then we have P minus x1. I mean, it obviously looks like, yeah, this is not good. It looks like it's going to be too much, but and that's the case. Right. X3, x1. Okay. And yeah, 1 minute. So 1 second. Okay. So x3 minus x1. So this x3 minus x1 itself is bigger than 1 minute. No. That's right. But just 1 minute. So x3 minus x1. This x3 minus x1 is going to be bigger than the total distance of any point, any other point Q. If you take any point Q which is inside, right? If you take any point Q which is inside, then the total distance of that point Q from x1 and x3, right? If you take any other point from inside, then inside, you see, the total distance from x1 and x3 combined, it is, it's less, it's equal to x3 minus x1, right? If you take any point Q inside, then the total distance is equal to this x1 minus x3. But for point P outside, the distance from x3 itself is more than that, right? So that's not good, right? And also, if a point Q is inside, then its distance from, oh no, but that's not. So if the point Q is inside, yes, if the point Q is inside, then, or rather, I should just say if a point Q is on the left of x2, right? Then its distance from x2 is less than the distance of P from x2, right? So this thing will be again bigger than Q minus x2, right? So it doesn't minimize. This doesn't minimize because if you take any point inside which is to the left of x2, then you see distance from x1 and x3 combined is not more than x3 minus is equal to x3 minus x1, okay, which is dominated by P minus x3 distance. And this last thing is also, okay, more for P. So it has to be inside, okay? P has to be inside the interval. And that's also like intuitively clear, but you have to prove it. So we have proved it. So any question about this? No? Chandan, you, Purbi, any question? Because this is very important. This part is extremely important. It looks very innocuous, but. Mm-hmm. Mm-hmm. No, but x2 is not the midpoint, right? X2 is not the midpoint, but still, I think your reason will work if you try to say, again, maybe think about it a little bit. It's not the midpoint, but you're right. I mean, at the minimum, but I'm just explaining, I was explaining part one. But yeah, you can directly say part, I mean, that will also good enough, right? Yeah. So find out. So yeah, so P equal to x2 is the minimizing. Okay. Okay. Chandan, can you say? I think, yeah, Raghav already said it, but do you want to say? Why the minimum is x2? I'm sure you have guessed that, but why the minimum is x2? I want you to say it in your words. Okay. No, no, no. Individual mods is lesser or greater? It's it's greater. No, no, but that's okay. It's greater. So, oh, but then you'll get a max. No, yeah, that's fine. Yeah, greater. But okay. No, but this will not give you the minimum, right? No, I don't think. Hmm. Okay, so you want to make, no, but you can't make this 0, can you? But you can't make this. Uh-huh. Okay, it's greater than 0, that's right, but then yeah, but you have maybe consider some casework, but then also you cannot make this. Hold on. So am I? Is this even correct? Okay. Okay. The problem is this. You can make this 0 by choosing p equal to the average of these three numbers, but this equality never holds then, right? Here you will not get equality. So this will be very small compared to this. So it's useless. I mean, you want a minimum, right? Which can actually be attained. So it will not be attained. Okay, that is a problem. So that method will not work. See, that method works when you have some geometric freedom, right? About angles and vectors, right? In more complicated questions. In this one, that usually will not work and it doesn't work. So, well, it's clear that x2 should be the minimizing point, right? You agree? It should be, right? But then, yeah, the reason is very simple because, well, I mean, if you, Raghav has already said it, but I'll just say it again. This point is, yeah, let's just keep it x2 only. When you take x2, just write it. If you write it, then there's no other way. It just comes. X3, sorry, this 1 minute. So then this is a x2 minus x1, and this is 0. Well, now you see this is equal to x1 minus x3, or x3 minus x1, sorry, right? That distance is equal to x3 minus x1. And even for this p, it is equal to x3 minus x1. Any p you choose, that is the case. Because this distance, that's why the first part is important. In the sense that it makes the problem simpler, right? The first part, it breaks the problem, right? So it tells you that p has to be inside x3 minus x1. Good. It's easy to prove, but it tells you the first step, kind of a hint. Once you know that, then it's easy. Okay. So for any other point p, or any point p inside, distance from x1 and x3 is not a problem. That is always fixed. The total distance is fixed. Okay. Distance from x3 is not fixed. Distance from x1 is not fixed, but the sum of the distance is fixed. Okay. And so that's important. So that's not, so there's no problem there. But then in the other place, x2 wins. I mean, x2 wins in the sense that x2 minus x2 0, that's the minimum. And otherwise there will be the extra thing. So for any other p, there is extra term, extra thing. And so x2 is the minimum. And so what should be the answer for the last case? Okay, so you've given the expanse. Okay, good. That's good. So let's try to, so this time I don't want you to say because you've got it. I want others to say. Yeah, so this was too easy for you. Okay, next time we'll do hard questions. No issues. So you see, I want others to say this time. Okay, so Raghav has already said the answer, and answer is fine, but I want others to say the explanation also. That is the most important thing. Now we have 2n plus 1 things in 0 and 1, and they are all in increasing order. That's important. And you can always arrange it, but okay. And you want to find a P which minimizes this thing. Actually, this hints that was given is good. Otherwise, this question is a little tricky. Okay, I would have maybe had a little bit problem because it's not a differentiable function, right? So you can't use derivatives and such so easily. So, anyways, yeah. Either ways, it's not difficult. So the claim, and obviously all of you can guess that the claim is that P equal to x2n. That's no xn. That's the middle one, right? Claim is that this is where it minimizes. So we want to explain that. Is that the midpoint? Oh yes, right. It's xn plus 1. Yes, it's the middle one is xn plus 1. So I want someone to say this. And maybe Raghav, you can think about this question. So this was on a line. Now if I give you 3 points on a triangle, basically sum of the distances, right? So I want you to, so these are 3 points, P, Q, R. So you can try to find a point X, no, P, find a point P such that, sorry, it's already P, right? Just keep it like that, find the point X. So I'm not giving you on a line, I'm giving you in the plane. PQR, now find me a point X so that this distance plus this distance plus this distance minimizes. No, no. It's not a circumscribed thing. Why should it be the circumscribed? Okay, think. So this is for you to think. And others can also try this and then we'll also discuss this. But now let us do this problem first. I'm erasing this. Okay, you can just note it down. Okay, basically a point where the sum of the distances from the vertices is minimizing. This time here, all the points are on the same line that it was in the plane. And then I have to think about how to do that for 4 points and 5 points. So n points, what's the method? There will be some algorithm, some procedure that you can follow because there is no order, right? But in this case, induction. Okay, how do you use induction? Uh, but we are going, let's do for odd number. Okay, so what's the conjecture for, what's the guess, what's the claim for or even number of points? Okay, so here you can see, so we are trying to use induction. Okay, but when you're trying to use induction, you're going to use the smaller cases, right? So you need a claim for the smaller cases. So for even, the claim is that it's the middle of the middle values. Okay, then P should be equal to x2 plus x3 by 2. But this is the claim. Okay, he is not yet proved it. ठीक है, induction से कैसे होगा, then how will you do? So for even, he is making a claim that for all even numbers less than 2n plus 1, it is the middle of the middle values. And for all odd numbers, it is the middle value where the minimization happens. But how are you going to build it from there to prove for 2n plus 1? So let's assume that it's true for all smaller values. How will you build it? How do you prove it? That's a general knowledge. That's a fact. But how do you prove it? That is the thing. Right. Yeah, I think that's what it's called for one point. No, but you see, you don't have to use induction. Try to use the previous reasoning that we did, right? So, well, you can use induction maybe, but it's very simple. So you take this x1 and you take x of 2n plus 1. So the way I'm drawing, you should get some hint. And so on. So on. See, just like we showed previously, you can show that P has to be between, P is between x1 and x2n plus 1. Same thing, same way you can show. Okay, just you can reason it, right? That if the P is outside, then again, you see the distance from, of P from x2n plus 1 is already more than the sum of the distances if P is a point inside. Maybe to the left or something. You can try to do it, right? If Q is inside, then the distance from x1 and x2n plus 1, that is less than distance of P from x2n plus 1 itself. And then for the other points also, right, Q is kind of having lesser distance than P has. For the other points like x2, x3, I'm just choosing Q in that way. Okay, so you can show that the Q has to be inside in between x1 and x2n plus 1. First step. What will you do after that? Well, if P is between, so P has come inside now. But then there is a benefit, right? If P is come inside, then this plus this is a constant. It's this in the last term, right? Once you prove that, then this is a constant. So you can basically forget about it. And then maybe you can say I'll apply induction, maybe. But then basically then induction is not even needed in that case. This is equal to x 2n plus 1 minus x1. So that part is a constant. Again, now the problem is for the smaller things, again, odd number of things. Again, you can show it's inside. Inside x2, between x2 and x2n, right? Again, you can repeat the argument, right? You can say again, we have an odd number of points, and again, it has to be inside. And you can just give a reason also, but in general. So that first lemma that we proved is important. And so it's again between x2 and x2n, x2 and x2n. Again, you can remove that and so on, right? You'll come down and you'll get 3 points in the next one. Okay, any questions? Otherwise, I'll clarify this, otherwise we'll stop for today. Yeah, so please tell me if there are any questions. Yes. So Chandan, would you like to explain? I think that will be good for everyone. Then I'll say, take your time, try to frame it. There's no rush, okay? You can explain, or then otherwise Raghav can also explain. Then I'll say in the end. Yeah, take your time, form the arguments. Okay, so that one, can you say more precisely? Right? So you feel that is not very precise what you said, like I say usually. Okay, say it more precisely. Ah, right. We are always counting this distance again and again, right? So that's one sense. That's one way in which you can say. Okay, let me say it in a different way. Just this part I'll say. I'll not complete the thing. I'll just come. Yes. Mhm. But can you? But yet that I think no one has yet explained clearly. Mhm. 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 Hmm. Uh, hmm. Yes, that I agree. Again, but again, it is not watertight, right? But it really depends. I mean, but yeah, it's right. There is no doubt. It's not right. It's right. And even what Chandan has said is right. But just to make it completely like logically, so there's no question of cutting marks. Just saying, okay, because these things can go a little bit wrong in higher dimensions. Okay, in one dimension is fine, but in 2D, so point is you can just be very clear and you can just say that I'll take an arbitrary point, compare with a point q which is between x1 and x2. Okay, then once again, who is shouting? Okay, you take compare it, right? Then you see p minus x1 plus p. So I'll write it here. But both of you, what you have said, I think Raghav, so you can say this obviously. But in both the cases, this thing is more than, it already beats q minus x1 plus q minus x2n plus 1. This is clear. This is like mathematically correct. And then, just I'm just repeating what you could have said. Okay. P minus x2 is more than q minus x2. So, x2 has having more difficulty and so on. And then you see, I'll add the inequalities just to be very, very watertight. Okay. Rigorous. Otherwise, it's correct. Okay. But just taking a point q, exactly showing that there is another choice of hospital, like just telling them that, okay, you put the hospital here and uh, uh, agent by agent, I'll compare and show you. Okay. Actually, it's not agent by agent, right? Because that you see, so that's why I said that you both of you's reasoning is not completely watertight, because the person checking the answer, there is this always this thing, right? Okay. But if q is inside, then it is possible that p is closer to x1 than q is closer to x1. But then you say, I'll pick q close to x1. Then, right, so then you have to make those things. So, but you have to say other clearly, okay? But yeah, it is fine. You can write it. So then what should be the next step? Okay, let me first write it, okay? That what we have already shown, that p has to be inside x1 to x. Okay, good. So then what's the next thing? So what's next? Think. Right, both the p's will get cancelled. Not x2 and x3, x2 and x2 and plus 1. Okay, yeah, or maybe you are, yeah, right. Both ways it's correct, right? So basically, first let me clarify this. So this will be this, okay? So is this part clear to everyone? That once you prove this thing, you get two things, right? Not just you get some more certainty about the point P, but you also simplify the question. Two things are happening at the same time. I mean, in the sense that both two good things are happening, right? So You see, right? Because this term also simplifies. Now, because it's simplified, this is a constant, so we can forget about this. So we can forget about this expression from the problem. Okay, because x1 minus x, this will be x1 minus x2n plus 1. It's a constant. So again, it's the same case, right? Now you have points like this point. So again, now I've said, saying this again, that you can just forget about x1 and these things. Again, you can do this. I mean, not do, you can just say it's the same reasoning. Again, this p has to be between x2 and x2n. And again, you can move on like that. Note that there are odd number of points. 2 and 2n hai, but there are odd number of points, okay? Between 2 and 2n both including. So you can repeat the same thing. Again, you can say that p has to be inside 2n and 2 and 2n. And so on and so on. Eventually you will get p is equal to the midpoint. So now is it okay? Or if there are questions, just ask. Where is the problem? If there is a problem, then any one of you can ask. So then there are no problems. Think, take a time, take a minute and think, and then I'll just end the class. Otherwise. Okay, so then it's good, right? So it was an easy class today. Yeah, okay, no problem. The next time we'll try to do the questions more faster. Okay, so yeah, so that's it then. Thank you. No, test paper we didn't finish. Yeah, we'll do it with the others. That will be a more